Welcome to this first video of lesson number 2, Pythagoras Theorem of Standard 10th Mathematics Part 2. In this video, we are going to recall the concept we have learned so far till coming to Standard 10. Okay. Now here there are four main things which we have studied before, and the first thing is Pythagoras Theorem. We have studied what is the statement of the Pythagoras Theorem. Okay, now let's recall what was the Pythagoras Theorem which we have come across in Standard 7th. So in right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. Let's take example and let's understand this statement. Okay, in triangle PQR, suppose this angle Q is given 90 degree. So this is the right angle triangle. In right angle triangle, say like PQR. The square of the hypotenuse. What is the hypotenuse? Hypotenuse is nothing but the side opposite to the right angle. So if this is the right angle Q, the side opposite to, or you can see, just ignore the Q and then you can see PR. So this is going to be your hypotenuse. So square of the hypotenuse. So here PR is the hypotenuse. The square of the hypotenuse PR is equal to. So this is equal to the sum of the squares of remaining two sides. So sum means it's addition. Remaining two sides are PQ and QR. So we have to take the remaining sides and its square and their sum. So it's sum of squares of remaining two sides. So in triangle PQR, if Q angle is right angle, the hypotenuse is PR and its PR square is equal to its PQ square plus QR square. Okay. So using this statement, if we know any two sides out of the three, we can find the remaining side. Okay. So we have studied how to find this. One more thing we have studied, that what is a Pythagorean triplet. So what is a triplet? Triplet means set of three numbers. Okay. So in a triplet of natural numbers, okay, triplet of natural numbers. So three natural numbers if we have together, if the squares of the largest number is equal to the sum of the squares of remaining two numbers, then the triplet is called Pythagorean triplet. Why it is called? Okay, say, so if these are the three sides of triangle, as here we know that hypotenuse is the largest side, and we know that square of the largest side. For example, here say, let's take for example here, so 3, 4, 5. Suppose this side is 3 and this side is 4 and this hypotenuse is equal to 5. Okay, so what are the squares of 3? 3 square is 9, 4 square is 16 and 5 square is 25. And now 25 is equal to, if you take the sum of this 9 and 16, if you take 9 and 16, its addition is 25. It means 5 square is equal to 3 square plus 4 square. Means, suppose these three numbers which are given to us as a three numbers, then the square of the largest number, the largest number is here 5. So square of the largest number is equal to the sum of the squares of the remaining two numbers. So that square of the largest number 5 is equal to the sum of the squares of remaining two numbers. And if it is so, then such number is called Pythagorean triplet, because these three numbers are the sides of the right angle triangle, and the largest side is nothing but your hypotenuse. So it is, this triplet has come from the Pythagorean statement only. That's why this triplet is called as Pythagorean triplet. Okay. So these three numbers denote the sides of a right angle triangle, which verifies this condition that square of the largest number is equal to the sum of the squares of remaining two numbers. Now you should be always knowing some important basic triplets. Okay. Why these triplets are very much useful in many topics. Wherever you find right angle triangle, there if you know the triplet, you can do the sums very quickly. Okay, you know the answers. For example, in the topic circle, where we know that the perpendicular drawn from the center of the circle, perpendicular drawn from the center of the circle on a chord, here this is perpendicular bisect the chord. So here when we get a right angle triangle, here we can use the triplet. Okay, so if you know the length of the chord, you can find half of it. Then this is the distance of the chord and this is the radius. So relation between the distance of the chord, half of the chord and the radius, it's nothing but your Pythagorean triplet. But still we can use this Pythagorean triplets in the topic trigonometry. Okay, so like that there are many topics we will come across one by one. Wherever it is possible, I will tell you that how these triplets are useful to us. But before that, as we know some tables, as we know squares, cubes, like that if you know the triplets, it's very useful to you. So here I have written some important basic Pythagorean triplets. The first triplet is 3, 4, 5 as we have seen over here. The next triplet is 5, 12, 13. Okay. So it means that 13 square is equal to 5 square plus 12 square. So 5, 12, 13 can be the sides of the right angle triangle, where the largest number 13 is going to be the hypotenuse. So if this is 5, this is 12, the hypotenuse is going to be 13, like that. 7, 24, 25, 9, 40, 41, 11, 60, 61. These are the 5 such triplets. If you observe some relation between this, that here the first numbers of the triplets are the odd numbers, consecutive odd numbers starting with 3. The next odd number is 5, the next odd number is 7, the next odd 9 and 11. Okay, and after these two numbers, so if you know this 3, after 3, 4, and these two numbers are consecutive natural number, 4, 5. After, when it comes to the 5, 12 and 13 is consecutive. For 7, 24, 25 is consecutive. For 9, 40 and 41 is consecutive. And for 11, after 11, two numbers come, 60 and 62. So these are the 5 triplets which you can learn very easily if you remember this relation between the numbers. There are some more Pythagorean triplets such as say 8, 15, 17, 20, 21, 19 and some more also. Say it is 12, 35 and 37. This is also a triplet. Yeah. So why do we call it as a basic Pythagorean triplet? Because if you take any one Pythagorean triplet and if you multiply by any natural number, the resulting numbers, whatever you get, 3 numbers, they are also Pythagorean triplet. For example, the very popularly used in questions, this is 3, 4, 5. Suppose I take this first triplet 3, 4, 5 and if I multiply this triplet by 2, the triplet I will get is, now if I multiply here 3 2 by 2, 3 2s are 6, 4 2s are 8 and 5 2s are 10. Now these 3 numbers are also form a Pythagorean triplet. You can verify this, that 10 square is 100. Okay, now 6 square plus 8 square. What is 6 square is 36 and 8 square is 64. So if you add these two numbers, we get it 100. So 6, 8, 10 is also a Pythagorean triplet. Now the same triplet, if you multiply by 7, suppose you multiply by 3, then you can get it 3 3s are 9, 3 4s are 12, 3 5s are 15 and so on. You can multiply any one of the triplet by such a number, say 2, 3, 4, 5. Even if you multiply by a fractional number, still you get it is Pythagorean triplet. So you need to remember this basic Pythagorean triplet, which are very much important and useful for you in mathematics, not only in 10th but for the latter mathematics, also for the higher mathematics also. Okay, after this we have studied so far 30 degree, 60 degree, 90 degree theorem and 45 degree, 90 degree theorem. Means what? Suppose in a triangle, the measures of the angles are say 30 degree, 60 degree and 90 degree. Then the side opposite to 30 degree angle. Here the angle A is 30 degree, so its opposite side is BC. So side opposite to 30 degree, that is BC, is half of the hypotenuse. Now here in this case, angle B is right angle, so AC is going to be hypotenuse. So side opposite to 30 degree, that is BC, is half of the hypotenuse. So BC is half of BC. And side opposite to 60 degree, that is AB side, it is root 3 upon 2 times of your hypotenuse. So AB is equal to root 3 upon 2 AC. Okay. And if the triangle is 45 degree, 45 degree, 90 degree theorem means in a triangle, suppose in triangle ABC, say angle A is 45 degree, C is 45 and B is right angle. In that case, the side opposite to B, so AC is hypotenuse. As we know that two angles are congruent, its sides opposite to them are also congruent. So at AB and BC, which are equal, and they both are 1 upon root 2 times of your AC, that is hypotenuse. Okay. So these two theorems we have studied in standard 9th, and the statements we have studied, we have solved sums based on this. Even we have used this Pythagorean triplet. I don't know how much you have used Pythagorean triplet, but whenever we will get across such use of Pythagorean triplet, I'll sure let you know that here we are using Pythagorean triplet. And for the questions like multiple choice question, these Pythagorean triplets are very much helpful. Okay, so this was our recall. In the next video, we will learn how to prove that Pythagorean theorem statement, how to prove this theorem. But before that, as we are going to prove that Pythagoras theorem, we are going to use similarity in right angle triangle. So we are in the next video, we will learn what is similarity in right angle triangle, what is that relation in that, and after that we will prove how to prove Pythagorean theorem and application of it. So this was recall, and next whatever we are going to study, I have told you. If you like this video, please give me likes and comments, and if you are not yet subscribed to the channel, please subscribe. Thank you.